Okay, hello everyone. Let's see, give everybody a few minutes to get in here. Um, while we're giving everybody a minute, if you've got extra questions that you want me to answer about AI, go ahead and drop those in the chat anytime during the webinar, and I'll try to get to those at the end. I do have a good chunk from the signups, but if there are new questions along the way, then please do drop them in. Um, okay. So today I have a different background. My Raspberry Pi died yesterday that runs my Whisper frame. So we have a new temporary background that I'll explain here in a little bit, and uh that's going to be it'll be a fun little activity we're all going to do here. Um, okay. So I guess we'll go ahead and get started here. I got a couple of topics that I want to go over today. Get my screen share going here. All right. So the first one that I want to kind of go through is a topic that I talked about in my newsletter last week, which is Google's AlphaEarth. And Google released AlphaEarth to some fanfare, or maybe self-created fanfare, a few weeks ago, maybe a month now, talking about how it's going to change analysis of the Earth forever and stuff like that. And it's probably a little much, a little over the top, but I think it is interesting. Um, and what I think is interesting about it is it does change the type of analysis that you can do. Um, and it specifically changes the speed that you can do certain types of analysis. And so the important part is that what it is it's an embedding. And you can use AlphaEarth without understanding what an embedding is. AlphaEarth will let you compare any two spots on the Earth and find out how similar they are using a set of data. But I think to really understand what you could do, or kind of what creativity you could get with AlphaEarth, I think understanding what an embedding is kind of important. Um, and I've talked about this before in other newsletters, but I tried a new thing. I used an AI to try to build an explainer. I'm not super happy with this yet, but we're going to walk through it here. And so the AI came up with this concept of GPS for ideas. It came up with this all on its own. And the source of this is I want to explain what just the generic term of an embedding is. And one of the easiest ways to explain that is talking about it in terms of geocoding. So as GIS folks, we're all used to this. You take an address like this and you run it through a geocoder, and it gives you back a latitude and a longitude. And so we're going from a piece of text that has meaning. It has meaning to me as a human. I can figure out where that street is, and I can drive down that street to get to that address number and get to that building. So we're going from this kind of built-in meaning to this latitude and longitude. And now the lat and long, like, it doesn't mean as much to me as a person right now. Obviously, like, there's only two numbers, and I kind of can figure out where lats and longs are on the Earth using some basic information about like where zero is and things like that. But it's past the first two digits of this. It gets quite hard for me, unless I have a really good map that I can zoom in on and measure. It gets hard for me to understand what these two numbers mean. It's much better used as a computer to understand it. But what's kind of even more powerful about this is once I have this as a latitude and a longitude, I can do lots of other types of analysis. So I can do things like find out how far apart things are, or I could search for coffee shops that are nearby me, using these latitudes and longitudes, just doing math. Whereas finding a coffee shop that is near my address is otherwise quite challenging because I don't know where it is relative to any other street. Like this piece of information, it doesn't tell me where other streets are, where it is relative to other streets. Um, but once I've converted everything to a latitude and a longitude, I can do that type of calculation. Now, we can make it way more advanced and way more complicated, and we can do things like comparing the distance across the Earth, but we can make it more complicated. We can compare the distance traveled, right? Like on a road or a sidewalk or something like that. But let's just kind of ignore that for right now. So if I can use geocoding to go from a description of a location to a latitude and a longitude, the idea of embedding is very similar. I'm going from an input, a text string, to a list of numbers that represent the meaning of that text. And so just like if I go over here and I change the number to 124 Main Street, I'm going to get an output that is very close in space. If I came to this embedding input and I said farmland with wheat crops instead of agricultural land, I'm going to get an embedding vector that is very similar. It's not going to be the same because it is not the same words, but the meaning is very similar. And so the output of those two things are going to be very close in this space. Now, this is often very high dimensional space. And what I mean by that is there might be many dozens of numbers. You know, for AlphaEarth, there's 64. For a classic text embedding, there's hundreds or even thousands of numbers that represent that meaning. And so the problem that I have of understanding these two numbers is much, much worse. Like I could draw two numbers on a graph. I could even draw three numbers on a graph, but four numbers, right now it's hard for me to actually understand what it is that I'm seeing. And if forget if there's 60 or hundreds or thousands of numbers, like I can't accurately see that or visualize it in my head. So it gets more complicated, but it has to be in order to embed, pun intended, the meaning of that text into some numbers. But what's really cool is once we have these numbers, we can do similarity analysis, just like we might calculate distances between points on the Earth. We can calculate the distance between two subjects or two sentences or two paragraphs of text, and we can find out if they're related or not. And where this gets really powerful is because the embedding is about the meaning, not the specific words. I could be able to tell if someone did a search for farmland with wheat crops or agricultural land with wheat crops, or even just land with wheat crops or farmland with crops. All of those things are going to be similar in their embedding. And so if we had a bunch of text about that content, we'd be able to say, oh yeah, they're asking us about this paragraph in this paper, right? By locating the content that is closest to that embedding using those numbers. And the reason that this is important to understand is because this is actually what AlphaEarth is doing. Imagine instead of a string of text like this, imagine that what it is it's one cell out of an aerial imagery. And we're converting that to a list of numbers. But instead of just that one cell out of that aerial photo, now we add on to it elevation and slope and environmental data, weather data, et cetera, like historic environmental data. We're adding all of that information on top of that. We could put lots of different data sets together and we embed the meaning of all of those data sets into a vector. So now if I had an arid climate on a mountain, that's going to have a certain set of numbers. And I could find other places that are arid and on a mountain by looking for embeddings that are close to me because it's representing the meaning of that data. And so that's what AlphaEarth has actually done. AlphaEarth has created this 64 dimensions in a vector that represents all kinds of different satellite imagery from Sentinel-1 SAR data, Sentinel-2 Landsat, canopy height, elevation models, climate data. It's brought all of that together into one vector. And from here, you can search to find similar things. And so this, my very simple playground here, if I click on one of these, you can see like a golf course, big like green open space, right? So that might be similar to an urban green space or wetlands, but wetlands are probably farther away. I don't know which one of these. They're wetlands. It's like farther the other direction. Or a university campus that has lots of trees on it, right? So the idea is that I could get any one of these locations and I can find other locations that are similar to me using this embedding vector. And that's really at least the initial power of AlphaEarth. So if I had like if I knew where if I had a cornfield, for example, and I knew what that corn has done over the last 10 years, I know what the yield is of that field, right? My embeddings here, my AlphaEarth, are in 10 meter by 10 meter resolution grid cells. So I could look at the historic values of all of those, and I could even train an AI model or a machine learning model to predict crop yield based on that embedding data. And then I could take it to other locations and predict crop yield in other locations and be like, oh yeah, we would have had good crop yield in this area because it's similar to this. And then I can further do a kind of traditional GIS analysis on it, but I'm focused. I have a starting point. I'm not looking at the entire United States or the entire world or my entire country and starting from scratch. I can use AlphaEarth to focus in on an area and give me a starting point when I'm doing like my crop yield analysis. And so I don't think that AlphaEarth is like fundamentally changing the way GIS is done, but it is a new interesting look at data. And it's using a very AI-centric process, embeddings, to start to analyze traditional data that we would normally use traditional GIS things for. And I think that it's important to look at it and figure out how can I leverage this, right? Just because it's labeled AI, is not why. It's like this is a new data set. This is a new way to interpret and look at data, and we should look at it. And there are going to be some really creative ways to use these embeddings. I don't know what they all are yet, but there's going to be them. And so like in text embeddings, there's some really, really creative ways to use them. So for example, you could use them to figure out which data sets might answer a question. Or you can use them to find information out of a large set of documents, find the bits of the documents that are related, and then feed all of that to an LLM to help it get the right context, the right background information in order to give you the answer. So a lot of the kind of revolutions that we've had over the last year in things like a large language model citing its sources better, a lot of that is powered by better embedding technology, not only by increased power in the large language model, but also by better embeddings. And embeddings are also what power when GPT says that or feels like it's learning from you. So oftentimes when you're using something like ChatGPT, it feels like it remembers or it learns about you. It's not. That large language model cannot do recursive learning. but it feels like it can. And that's because the embeddings are so good at pulling relevant information from previous conversations and reminding the AI about that conversation so that it's in that context window. That's actually what my newsletter this week is about. So there's a small spoiler for what's going to come out tomorrow. Um, okay, but these embeddings are even more powerful. And so one thing that I wish that this technology did is I wish that text played a role here. Remember at the top, we were talking about taking text and building an embedding. And AlphaEarth doesn't have anything to do with text. There's no text in AlphaEarth. It's only the source data. And that's that's a limitation. And the reason I say that is embeddings also power image generation. So, right, over the last year, just like a lot of AI things, image generation has gotten a lot better. And one of the ways that that's gotten better is because of embedding technology. And let me explain how this works a little bit. So in my episode 28, so last week's newsletter, there was um, where is it? Yeah, there's a link to a YouTube video here. And in that YouTube video, it's a little bit long. It's like almost 40 minutes, but it's a really good explanation of how um, image embeddings work and how image generation works. It doesn't get too heavy on the math. It's pretty friendly. So I highly recommend it if you're interested in how these things work under the hood. But imagine if we took down here at the bottom, if we took the text, a photo of a cat, and we embedded that using what it's labeled an encoder here, but let's call it an embedding to get a vector of numbers that represent it. Now, imagine if we did that same thing with an image. We took an image of a cat, we embedded it, and we got the same set of numbers. If we built these encoders so that they are using the same output, they have the same meaning, so I can compare these two numbers, then I know that a photo of a cat is similar to an image that produces a similar embedding value. And what that enables me to do, and I'm not going to dive into this. If you want to know how this all works, watch this video. What that enables you to do is build what's called a diffusion model, which generates an image from an embedding. So now what I can do as an AI designer is I can build a process that takes text, encodes it into a vector, and then uses that vector to build an image. And meanwhile, what I'm doing is I'm testing to see how far away is this image from my output vector using an encoder. So I'm constantly checking to see how close am I, and I'm progressively building my image to get closer and closer to my embedding. It's actually why in a lot of image generators, you'll see an image start with low resolution and get to more and more high resolution. That's actually not a UI design. That's actually an artifact of the way the models work behind the scenes. They actually recursively improve. So imagine that something like AlphaEarth could go from a location, a data set, or a set of data sets to a vector, and that vector could be compared to a text description of that location. Now we're enabling like search across all of this embedding, across all of this data to find locations on the Earth by describing an environment. I think that would be incredibly powerful. And I think it's quite hard. Otherwise, Google would have released that. So I have no doubt that they're working on this. There are people continuing to work on AlphaEarth and are probably going to start making these types of embeddings in the future. So there's a lot more to come here. And I think that's one reason why it's really important to start understanding how these embeddings work and how experiment with how to use them, and how to enhance analysis using these embeddings. And similarity search is the easy, obvious thing. So that's where you start. But there's gonna be more there. There's gonna be more other interesting things that you can do, like predicting crop yield and stuff like that. There's gonna be more interesting things. Okay, I'm going to stop there with AlphaEarth. I'm going to check to see if anybody's asked any questions about that while we've been going. Hope I don't see anything. Thanks for posting those links. Um, okay, so we're going to switch gears a little bit here. So I mentioned at the beginning when I showed this site that this site was built by an AI. And it was built with the idea of kind of building an explainer that walks you through what is an embedding relative to a geocoding. And this isn't perfect yet, right? And there's things like this try it yourself section, which is just totally made up. So there's work to be done here. But this first draft got made in just a few minutes, by me taking these different data sets down here, these different documents that Google created, different websites, different papers, excuse me, pulling that together in Claude and talking with it about the idea of using geocoding as an analogy. And then it created, I used Claude to create an outline for how this might work, how this might be presented. And then I took that and I fed it into my own app builder to build this application. And so that's what I want to show next and talk about. I've referenced this a little bit before in other webinars, but this has gotten to the point where I can use this and I use it every day, and other people can start using it too. So I built that using this is my app builder. And if we go look at this GPS for ideas thing here, so we can actually see the formatting's messed up. This is a work in progress. Okay, this is an app being built while we're using it here. But we can see the conversation that I've had with it, where I gave it a whole slew of background information about what I wanted it to do here. It thought about it. It asked me some questions. I gave it some answers. And then it built that. Now it takes a few minutes to do that, but it uses AI using prompts that distill my knowledge about building software down into building an application like this. How would I do it? How would I go about building a plan? How would I go about executing that plan and building that? I've tried to distill that down into this app builder, and especially make it work with ArcGIS Online and ArcGIS Data and ArcGIS JavaScript SDK. So we're gonna play a fun game here. So as some of you, or maybe all of you know, when Dymaptic goes to conferences, I like to do something different, like printing stickers that are AI generated. And so for the upcoming conference cycle, starting in the fall here, we are building a new system that generates fantasy maps. And so I have a very simple version of that, version 0 of that we're going to play with today. So what I'm going to ask everybody to do is fill out this survey 123 form that I'm posting in the chat here. It asks for your name and your email and a LinkedIn profile. You don't have to give it a LinkedIn profile. It would go and scrape the About Me section of that if you put it in there. You don't have to. But do type something into the About section, right? The more you put in there, the more custom the fantasy map is going to be. And then you have to upload a picture. That picture is used as reference. It doesn't actually get embedded into the image in any way so far. So it can be a picture of you, it can be a picture of a dog, it can be a picture of your desk, whatever. Eventually, all of that's going to get melded together more, but it's not all completely done. But I want to walk through how this works. So when you fill out this form, right, you go and you fill this form out in Survey 123 and you hit submit. it fires a webhook. And when it fires that webhook, this is what's listening. This is a workflow in an application called N8N, like November, the number 8, November. And it's very similar to tools like make.com or Zapier, except it's AI first. Makes it really easy to integrate AI agents and AI workflows directly in with a regular workflow. And so let's just walk through what happens here when we do this. So this webhook comes in, and we check to see whether or not you've included a LinkedIn URL. If you have, we go get it, and we run a little bit of JavaScript to extract the About Me section out of it. Mostly, the reason we're doing that is because I found that this page is so long that it often overflows the context window of an AI, or it's very expensive to read it because it's filling up. There's a lot of characters in there. So I just want the About Me text. So we extract that. If you don't give it to me, we just fill it out as blank and we go on with life. We get an ArcGIS token because the layer behind this is secured. We extract the attached image. So whatever it is, we download it and we encode it base 64 so that the AI can read it. Then we send all of that information. So name, about you, whatever you typed in, your LinkedIn profile, and the image. We send all of that to an AI. In this case, I'm using Anthropic's Claude 4.0, Sonnet 4.0. And I have a very simple prompt in here today, right? This is just the very beginnings of this. Generate an image prompt for a detailed fantasy map based on the information given. So I'm not actually generating the image yet. I'm generating the prompt for an image. Okay. And so you can see in this example output, it's something like create a detailed fantasy map showing a mystical testing ground called Tester's Domain, right? So this is one of my test ones where I said my name was Tester3 or something like that. So we use the AI to generate a description of the image, an image prompt. And remember what's happening, we talked about this a little bit ago, is we're turning that into an embedding, right? And that embedding is powering that image generation. So once we generate this prompt, we make a call to my custom image generation endpoint. And it returns back to us a URL, takes about a minute, that generates that image, that gives us that image. Then we do one more call to an AI agent to generate a title for the image. So basically, we're giving the AI the previous prompt, the image prompt, and we're asking it to generate a title. We could do this all in one step, but I thought it was fun to include two just to kind of demonstrate that you can do multiple calls to an agent. And then we format all of that output, and then we save it back to the ArcGIS Online layer. So now we need a way to see this. Well, the way that I did that is I created an admin page. And in this admin page, oh, my authentication is broken. There's a small bug that, whoops, I didn't mean to hit edit. Oh man, okay, hold on. Small bug with authentication that I have not fixed yet that is a little bit embarrassing now that I thought it wasn't going to happen, but it's fine. Um, this, this, I had the AI build me an app to view each of the results. So I can tell nobody has filled it out yet because there aren't any extra layers. There aren't any extra entries here. So somebody should definitely fill this out. Come on, guys. So when I click on one of these, I can see the image that it generated for that entry, right? And so I can look at any one of these. Yeah. right? So I was able to build an app that does this just from a prompt. Um, and what might be more fun is if we had a way to view all of these images at once. So let's have the AI build an app right now that's going to let me view all of the images. So we're going to go to create an app and we're going to say, I need an app that can show all of the images in a full screen mode for my fantasy map generation tool. I want to see the title and the image, and when I hover on the image, I want to see the prompt for it. Show each one for just a few seconds and then move on to the next. Something like that. So we give it a prompt. We come down here, we're going to find our data set. Where's our public one? There it is. Dynaptic Fantasy Map Creator public view. So we're going to do that and we're going to hit go. And what it's going to do is it's going to go look at the data. It's going to look at the fields that are available. It's going to query the data set. It's going to look at the data. It's going to look at what I asked for. And then it's going to ask me some clarifying questions about my app. So it's basically causing me to think a little bit harder and define my application a bit more. So let's see what we can do here. Are there values in the image URL field already public? Yes. The URLs are public. You can just use them. How long would you like each to stay on the screen? Let's say 5 seconds. Should the image's title always stay visible on the screen or only appear when you move the mouse? Let's say the title should be always visible and it should be formatted like a fantasy map using browns and parchment colors, something like that. When you hover or tap on phones to show the prompt, you want the prompt as a small tooltip, full width, caption bar, or something else. I don't know. Something that looks nice and is readable. I don't know. Do you care about the order in which the images appear? Random shuffle, more images will be added. Just to confirm, this app does not need to show a map at all, just the slideshow. Yes, just show the slideshow. Okay. Oops, slideshow, not slideshow. Send. Okay. So we're gonna let that cook for a few minutes. So this does take a few minutes, because what it does is it goes and it looks at the data again. It looks at your original idea, looks at the answers to your questions. It generates a plan. So it defines what it's going to build. It creates an architecture for the app. Even a simple app like this, it creates an architecture, right? It's kind of following best practices. Then it takes that architecture and it goes and it builds the app, which might be generating just one HTML file. It might be generating like CSS, HTML, JavaScript, pulling all of that together. In some cases, authentication is required. And so it will automatically integrate that so that you don't have to deal with OAuth authentication. The application handles all of that for you, and builds that application. So this is going to take a minute or two, and shortly it's going to start giving us updates about what it's doing. But in the meantime, I want to go look at some other example apps that I've built. So while that's building, just some other kind of things that I've done. We looked at the GPS for Ideas site. I actually have this one where I have a list of people that I want to connect with on LinkedIn, and it helps me keep track of that. It's actually stored in a private feature service with the information. And then when I click on each person, it actually uses AI to generate a custom message. so that when I send a connection request on LinkedIn, I have that custom message to get me started. I usually tweak it, but it gives me a sample. Oh, here's a good example of an app that um, does some GIS. Actually, does some GIS. So in this case, what I have is I have a couple of polygons, and this is a very specific process that I was prototyping. So I can click on a polygon, turns red to select it. Then I can come over here and I can draw a new polygon. So say this area here I'm interested in. And when I take that, I'm going to buffer that by, sure, 10 meters. And what's going to happen is it's going to buffer it and it's going to then subtract it out of that final polygon and return that back to me, right? So I was just prototyping this, but this took me just a few minutes to build in the app builder because I was able to basically just write down the workflow that I wanted, and then it wrote the code to do all of this. And what was interesting about this one is that it actually didn't work the first time. And the problem was spatial references. The code, the AI builder assumed that if geometries were in different spatial references, it could just call things like clip or intersect, or subtract, but you can't do that. They actually all have to, everything has to be in the same spatial reference for the geometry engine to work. So I had to explain that to it. And then I went back and I updated it so it had that information. So hopefully it won't make that mistake again in the future. But so you can build semi-complex GIS workflows very quickly, right? Maybe this isn't a production ready app, but I have a proof of concept that I built in just a few minutes, which is really useful. There were some other ones that I did. So this one was pretty fun. So a couple of weeks ago, Dymaptic had a hackathon, and actually I should show you the hackathon prompt app. And we did this to give everybody some time to learn more about using AI tools. And so we divided up into small groups, and I gave this prompt to everybody, and everybody had 8 hours to build an app as complex as they could. You might have seen the posts about it on LinkedIn that explains the different apps and had screenshots. So I built this app using AI again to build this. And then each one of these, it actually had a countdown timer. So each team had a different time window because of time zones, and it's complicated. And so everybody had their own countdown timer to refer to. But at the end, one of the scoring processes was for everybody to vote. And so I built a ranked choice voting application using AI. So like, for example, if I go click on my cake flavor here, a bunch of different people have voted. And when you vote, you actually are ranking them in the order of preference. If you live in Portland, Oregon, you're used to this because we switched to ranked choice voting recently. But you rank them in the order you want. And then the application executes ranked choice voting with instant runoff and explains each round to you. So in the first round, strawberry received no votes, so it's out. In the second round, key lime, lemon, rhubarb, pecan pie, they only had one vote, so they're out. And then we were down to vanilla and chocolate, and vanilla won with 4 versus 3. And each time a candidate is removed in a round, the votes that went there are removed, and it goes down whatever the next choice is that's still available, they get moved. So if this person voted for key lime, voted for dark chocolate as right below key lime, then their vote gets moved over. And so you end up with the final vote. And so I actually just went back and forth with the AI to build this voting application, which uses Survey123 to collect votes. Or, well, not Survey123, but I used Survey123 to build the schema. So I built the data set behind it all in ArcGIS Online. And then and then the AI built the process, the algorithm to count the votes and explain it and walk through it. So you can build lots of different weird things, but I'm always using ArcGIS as my backing data store so that I don't have to have databases and things like that, just using ArcGIS. Okay, so let's see if our build is done. Oh, not only is it done, it is working. So we can see on the right here, the preview is paging through every few seconds different images that have been submitted into the app. So there's definitely a couple of new ones here that I do not recognize. Um, so we can also go back to the dashboard here and let's go over to um, the admin page. We can see, oh yeah, we've definitely got a few now. So I can click on some of these and see what oh, that one's still generating. Okay. Uh, and that one's still generating too. Okay. So we're still, oh, come on, go away. Okay. So come down here. Twilight Realm of Sleeping Gods. That's pretty good. That's cute. Uh, so anyway, this I'm really I'm really pretty proud of this app builder because I've been using it almost every day to build new things. Whether it's a prototype because we get an RFP and I want to see like how hard is it to build this application? Can the AI do it in one shot by me describing that workflow? Or it's this fantasy map generation app here where we're generating um, uh, fantasy maps. And the goal is actually to do something much more complicated here, where the generated maps are actually georeferenced in a real map and are placed so you can kind of pan and zoom and interact with them in different ways. So there's a lot more to come here. Um, and it definitely has bugs. But if you have an ArcGIS Online account, it will work and you can test it out. I will say clicking on one of these is not very interesting. Like if you don't know what to do, ask it to build a hello world map or something that randomly changes the base map when you click a button or something like that. Or give it a data set, pick a data set from your ArcGIS Online and ask it to make a map with a table. I've done this several times with like my March Madness data set. I'll ask it to build a map in a table so that I can click on a row and it shows it to me in the map and I can interact with it. It does a really pretty good job of building an interactive thing like that on the first try. Um, yeah, okay. So I'm gonna see if my background, the app behind me here should be refreshing eventually with new apps. Um, but maybe we'll just pull this one up and let it change periodically while I go look at um, I go look at questions that we've got. We've got 15 minutes or so. So I think I'll go pull up questions that we got submitted from earlier and we'll go through those really quick. If you've got other AI questions, please drop them in the chat and we'll get to it. Okay. So the first one I've got here is, why is AI superior to natural intelligence if it hallucinates in the same way? I kind of love this question because um, I don't actually think that AI, artificial intelligence, is superior to natural intelligence today. Um, it's interesting that this person said that it hallucinates in the same way, which I think it does. I think the human brain also fills in gaps and makes things up in very similar ways to AI. Um, although it is more sometimes more obvious when AI does it because it's very confident about it. It's more confident about it than we are. Um, and the one area where I think that AI is superior to us is it is faster. So I can use AI to write a couple hundred lines of code in a minute or two while I'm talking to you all about the way it works or about different apps. But and I can't write code that fast. right? I could not have built this application that's showing me these different things. Like, let's just go look at this code. Um, go over here to edit and let's go look at it. Look at the code that it built. So it did it all in one HTML file. It made roughly 558 lines of code in 4 minutes, 4.5 minutes. So I mean, I cannot write at 100 lines of code per minute, especially not HTML and a bunch of JavaScript and a bunch of CSS. So like to me, this is where like AI is faster at writing that code. It's not always right, but it is faster at generating that output. And I think today that's probably one of the most powerful things that AI can do for you is it can make you faster. It can make you more efficient. It can make you get more done in less time, whether that's writing code like this or proofreading documents or doing other things like that that involve text. Where it's not so good, it falls over on very simple tasks. So, like a friend of mine tried to use the ChatGPT agent to book a rental car for a trip coming up. It didn't go well. Um, I think it did actually book a rental car, but it did it all wrong in the wrong location, like the wrong city, wrong dates, like it did everything wrong. And then he had to like call the rental car company to cancel. Like it was kind of nuts, I think. So, like, I think for that kind of activity today, it's not very good. But it is faster than we are at things. And I think that's where it is better in some sense than we are. And I think it's only going to get faster and more intelligent as time goes on. So we're going to see it get better at those tasks and at other tasks too over time. Um, yeah, I think that's I think that's kind of where I think that's kind of where I am on that. Um, I don't think it's always superior. I think there are very specific things that it is better at, and there are specific things that it might be better at than I am. Um, but generally speaking, I think it's not superior to us today, but it does have some things it can do better. Um, but I also think that we are at the very beginning of AI. Um, it might be that it takes 10 years to get to something that is truly human level, or it might be that it takes 2 years or 50 years. I don't know. But we are at the beginning of this. The models next year are going to be better. The models 5 years from now are going to be better than we have today. So we're just at the beginning of what these things can do. We're only going to see it being able to do more. So we're only going to see it getting better at tasks that humans can do. I don't think we're going to see it's not going to regress. We're only going to see better, I think. Oh, question popped in. Can you play chess against ChatGPT? You can play chess against ChatGPT. Um, it actually, if you, oh, I forget the like chess notation where it tells you like it's moving this piece from this spot to that spot. It can actually just output that notation to you. So you can play chess with it just without an application. Um, and this was actually an area of focus for maybe it was GPT 4.0. I think it was when GPT 4 came out, excuse me, when GPT 4 came out, it could not play chess very well. It could make valid moves, but it wasn't very good at it. And it they did additional specific training for the 4.0 release to get it better at doing that kind of thing, and it helped quite a bit. Can it play card games? It can play some card games, yes. Um, and I have definitely done game nights with friends where I was being a pass-through for the AI, and I was just doing exactly what it told me to do, taking pictures or typing in what the current state of play was. Um, I would say it was mostly successful. but I'm eager to see what it can do more there. I haven't tried things like poker myself. I would imagine it could do stuff like that fairly well, but I don't actually know. I haven't tried that. Um, yeah. Okay, so a few more minutes. So, next question. This is one's more of a comment. Very excited to see how you're using AI with ArcGIS outside of built-in AI options. Yeah, so the first thing that I'm releasing that is this kind of data exploration app prototyper thing that I built here. And there's several things about this. Is one is it understands data. It understands ArcGIS data sets. It can query them. It can look at the schema. It can look at the metadata. If you have good, strong metadata in your layer, it's going to be able to read it and interpret it and understand what those fields mean and make good guesses about how the application should be structured. Um, the more um, the more metadata you have in the data, the better your data sets are documented, the better it is at understanding them. But it can query them and understand them, and that's one of the things that it's really good at. And I've got some other things coming inside this structure that's going to allow even more data interaction with my goal is for it to be able to answer simple GIS questions eventually by writing an app. So having it be able to find other data sets that might better supplement what you're doing. So that's coming. But for right now, I'm focusing on generating this code and making it better at understanding the Esri SDK and the Esri environment and really building that. And that's why every one of the apps that I'm building here, even when it's LinkedIn contacts or this Polygon or rank choice voting, my back end is ArcGIS Online because every time I'm doing that, I'm storing that data in ArcGIS Online so that I can continue to refine the prompting and the background and the embeddings to make it better at writing that code, because that's what the secret is behind the scenes, is those embeddings and that knowledge that it has access to about the ArcGIS environment, the ArcGIS SDKs, how data works. Improving all of that integration is really the secret behind a lot of this. And that's also what I'm good at and what Dymaptic is good at is understanding that for clients and helping integrate this. And so this is really trying to uh, embed that knowledge that we have into an application, which I find kind of fascinating, right? Can't do everything, but can do really cool proof of concepts like the Polygon sample app where I have the polygons and I want to cut things out of them, like following that workflow. That came out of a client request. Like I was trying to see, like, can I build this quickly? Um, so there's more to come, and where Dymaptic is also tooling up to be more AI first, both internally but also externally for clients, which is a good lead in to the last question that I'm going to do here. So I'm going to have a few minutes left. Um, have any local government agencies operationalized any AI processes? And if so, would love to hear about them. So there are a few that I have seen or we've helped create or that I've heard about. Um, and it's mostly for us when we implement them, it's mostly about finding kind of novel ways to use it. It's not just building a chat bot. It's like putting it into um, generate or to match data correctly. Like a user uploads data and we need to field map it, right? So using AI to generate the field mapping based on not just the names of the fields, but the content within them, like querying the data, understanding it, and doing that field mapping. Doing that kind of work, protecting data input, doing things like generating a prompt for like my LinkedIn. So doing things like that, like generating the email in a permitting app where it's like, oh, this, the AI can be programmed and shown to look at, oh, this permit request is invalid because it's missing X and Y and Z. It can generate that email that you need to send. Maybe you don't want it to send it on its own. that's okay. Like human in the loop is totally valid. And but you could use AI to pre-generate it, and then you spend another minute, tweaking it so it's correct. Maybe you even update the AI so that it does better next time. That's what I'm doing when I'm building apps in here. But um, um, generating those emails, generating that communication ahead of time for you, it doesn't have to send it, but just generating that text, even like even if you don't like the output, it often is a great way to get your brainstorming going. Um, the other kind of interesting thing is there's a paper that came out of an MIT lab a few weeks ago. Um, and the headline of it, I think I have a link here. Let me see if I have a link to this. Yeah, here we go. So well, this isn't the original paper. Maybe I'll probably do a newsletter about this, but here's that link. You can probably find the original paper from here. But the headline that everyone talks about is this: 95% of all generative AI pilots are failing. And I haven't dug into this to find out how true it is yet, but I think it probably is at least somewhat true. And the the interesting thing is there's a couple of things where they talk in this article, they talk about um, why do they fail? And the difference is almost always a learning gap. It's a learning gap for knowing what tools you can use, and it's a learning gap for your staff within the organization to learning how to use the AI tools. The other thing that I think is kind of interesting is that implementations have gone better when you enlisted a specialized vendor or specialized expert consultant to help you learn and get educated about what the AI tools can do and how to implement them. And so Dymaptic is focusing on doing this within the GIS space to become one of these specialized vendors, the specialized vendor for implementing AI in a GIS environment and um, leveraging AI to increase the capabilities of GIS. And I think it's about, like any type of automation, it's about not changing your process because the tool needs it in this other workflow, right? That never works. Even traditional automation platforms, if you create a brand new process that doesn't do what the old one used to do, but now it's automated, a lot of those failed. And I think with AI, it's very similar. You you want to automate your process. You want to augment your processes with AI. And so picking a workflow that has some low-hanging fruit in it and finding pieces where AI can help you. It can write that email for communication. It can help you do version 0 of the field mapping. It can review input data and look for errors. It can protect input so that a free form entry that a user puts into a data set doesn't have bad words in it or things like that. Things that are classically very hard to prevent. And so I think finding those low-hanging fruits and implementing those is really the secret here. And that's what Dymaptic is skilling up to help people do. Um, okay. We're just about out of time. Let me see if there are any other things in the comments. Tried ChatGPT to create a design in Fusion 360. It's too difficult to describe the details of what you want to do to design it beyond a 3D rectangle. Yeah. I I've also tried getting AI to generate G code directly. Like G code is a programming language for like 3D printers or for pen drawing tools and things like that that commands, move the print head here, draw an arc from A to B. That's what G code is for. And it's a common platform. And it's really bad at it. It's really bad at generating even the simplest things. Draw a circle. It really struggles with that. And I was just trying to get 2D drawings in G code that I could then use. Um, I wanted to build an AI powered pen plotter. I'm still working on that project, but um, but the LLMs can't today just output that G code. It's not very successful at outputting that. Not like it is at Python or JavaScript or HTML. All right. I'm going to leave it there for this month. So thank you everyone for coming. We're going to do another one of these in a month. And in the meantime, check out my newsletter because the one coming out tomorrow will be more about embeddings and why AIs don't actually learn, even though they look like they do. So that's going to be a fun one, and I've got more fun ones planned. So thank you. Um, Oh, can we see the other fantasy maps? Yeah. Let me take, let me see here. Do, 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 do. Oh, app builder, fantasy map, settings, publish, copy. I actually don't know if this is going to work, but if it doesn't work, I will fix it so that that link will work. So save that link and it will work in a minute if it doesn't work, because I will go fix it right now. Thanks, everyone. And I'll see you next month.